Lecture 6.6, Two-Lens Systems. Many optical instruments use a number of lenses together to get more magnification. Compared to a single lens can provide. The process goes something like this. So the first thing that happens is that lens 1 takes the object S1 and produces image S1 prime. It's a single lens. Image S1 prime is now the object for lens 2. So that means here that the object S2 is proportional to S1 prime. I mean, they're the same, but you'll see that the distance is different. 3. Lens 2 now creates a final image S2 prime. So in summary, the final image is located at S2 prime from lens 2 and is magnified twice. Once by lens 1 and one by lens 2, where the total magnification is the product of the two. So one has to be careful when identifying whether the image is real or virtual. And the question is, why? For a single lens, we know inverted images are real, while erect images are virtual. this is not necessarily the case for a two-lens system. What you'll find here is that in the end, the location of the image will tell us if it's real or virtual. So if I pick, so let's say that I have something like this. Let's get a nice thick line to separate my lens here. Now, when you look at this thing, this guy, if it lands on this side, what we're going to find here is that if the image is on the right side, that implies that it's a real image. By the way, this is lens 2. But if it lands on the other side, then the left side, this is a virtual image. So as examples, I can have inverted real or inverted virtual images. Or I can have erect real or erect virtual. All of these possibilities exist. The most common multiple lens systems / instruments are the compound microscope, and the refractor telescope. So let's go through both of these. So here's the compound microscope. So a compound microscope uses two optical lenses whereas a simple microscope is a magnifying glass or a magnifying lens. So what is a microscope? Well, we know that it's an instrument that enlarges objects that are really small, thus relieving details too small to be seen by the unaided eye. I believe that the first microscope was made around 1600, just before that. And I remember it being a father and son team that actually created it. But where the microscope really became famous was by Robert Hooke, where he used the microscope to make studies. So here's sort of like the image of a microscope. And so if I look at this image, there's a couple of things that we should pay attention to. The first thing here is that here is where the object is placed. So this red object is the object. And when I think of the object, we call that S1. Now what you're seeing here is that there are 3 lenses. Okay. So in this case, I'm going to pick this one, but there's 3 of them. And this here, this is lens number 1, but this is known as the objective lens. And then the second lens is this guy right here. And this lens is known as the eyepiece lens. So just to clarify the language here, I'm going to say that this is lens 1 is called the objective lens. Produces a real inverted image, which we call a real inverted image, that we call that image S1 prime. Now, what happens next here is that lens 2, which is the eyepiece, views image S1 prime and magnifies it. As in inverted, wait, not inverted, as in erect, virtual image, which we then call S2 prime. Now we gotta be careful with the language. The image of the object is inverted. Lens 2 doesn't create an erect image, it keeps it inverted. And another thing that's worth mentioning here is that lens 1 has a longer focal length than lens 2. In other words, f1 is greater than f2. So let's get a little bit more in depth with the details. And draw a ray diagram. So the first thing that we have to do here is we need to choose an objective lens. Remember, I call that lens 1, where object S1 is in between 2F1 and F1. By doing so, the object is magnified. By magnification, M1, 2. Now we choose an eyepiece lens, which is what we call lens 2, where image S1 prime is just inside the focal point of F2, such that F2 is greater than S2, but remember, is now proportional to S1 prime. 3. The eyepiece now will produce an erect virtual image that gets magnified. Again, by M2. So finally, the object has now been magnified twice, such that the total magnification, which I'll write as just big M, is then M1, M2. So let's take all these words and let's draw a ray diagram. So I've already set up my system to make sure that I can move quickly through this. So here I go. Oops, I only produced one of these, so I'll have to copy it. So there's one, so let me copy this guy. I'm going to paste this. So I'm going to do 2, 4, 6, 8. So here's my two lens system. So for the time being here, I'm going to pick this as F1 greater than 0, F2 greater than 0, which tells me that I have two converging lenses. Now what I'm going to choose here is I'm going to choose focal points that do something like this here. So the first focal point I'm going to choose, I'm going to pick this guy to be right here. So the first one's going to be, let's say, I'm going to pick this guy to be 2.5. And then this guy's going to be right there. So this is 2F1, F1. So on the other side, I'm only going to show the F1 right here. So now what I'm going to do here is that I'm going to create an image of an object. So I'm going to take my object and I'm going to smack it right in here. Let's say I'm going to put this guy right here. So there's my object. So now what am I going to do? I'm going to draw my ray diagram. Here's ray number 1. Then I got to go through the focal point. And then I'm going to erase some of this ray just to clean it up. So for starters, I'm just going to go all the way down to about right here. But remember what I said, I'm going to erase that tail end. So now I'm going to have ray number 2 here. So I'm going to cross this guy. And then there, oops, that does not work. I got to go through here. I'm going to say that I now produce an image right here. So I'm going to say that this is my image S1. So to clean this up, like I said before, I'm going to erase this amount of the ray. So I see that ray number 1, ray number 2 goes like that. So if I look at what I see about this ray, here's what I'm seeing. This here represents my object distance from here to here. This is S1, that's my first object. Then I have my image distance, which is S1 prime. It goes from here to there. And this is S1 prime. So now that I have that, what I'm going to do here is that now I'm going to pick my focal length for my next mirror. And this guy right here, I'm going to call F2. Now, because this is a converging, I need the far focal point, which is then going to be right here. So now I'm going to create my images again. And here I go. So my first image, my first ray, I'm going to use a yellow one. It's going to go from here to here. And then I'm going to move up and it's going to go through the focal point and then I'm going to follow it backwards. Now some of this I'm going to erase to clean it up. So this is my ray number 1. Now I need my ray number 2 here. So the ray number 2 has to go through the center of the lens. And I see I did not go far enough, but there's the center of the lens. And then I need to go back. So then coming back with my yellow, I'm going to go like this here. And you could see here that this guy is going to cross right there. So my ray goes like this. So now I have a final image. What is this final image? Well, I'm going to give it a color. Let's say that I'm going to get this pink. And so if I look at this, this is my final image right here. So if I look at these distances, what am I actually seeing here? So the first distance that I'm seeing is that this distance from, I'm going to take this F2 and I'm going to bring it down here. So my S2, my image is from this distance, from here to here. That's S2 prime. And then you can see here is that this distance right here, from here to here, this is related to my object distance, S2. So that's my final image. So I'm saying that this here is my final image. So what do I know? The image characteristics are inverted, larger. Remember, inverted in a single lens always means real, but in this case, this is a virtual image. It's not real. And what we're seeing here is that the reason why this is virtual, because it's on the left side of lens 2. So in the language of the microscope, or just of optical instruments, here's what we find. We say that the magnification then is the magnification of the objective lens, which is the first lens, and then the magnification of the eyepiece. But in our language, we'll just call this M1 times M2. Now let's look at a simple telescope. Okay, so let me move this up. Let's write this out. So I'm now going to look at a simple telescope, and this is called a refractor. If it uses lenses, it's called a reflector. If it uses mirrors. So a refractor, if it uses lenses, or if it uses mirrors, it's called a reflector. A telescope is very similar to a microscope. And that makes sense here. What does a telescope do? It takes tiny objects, stars in the sky, and it tries to magnify them, just like a microscope. So a microscope and a telescope are effectively the same thing. But there is a difference here. So what you're going to find here is that it's very similar to a microscope where the objective lens now has a short focal length, while the eyepiece has a long one, which is opposite of a microscope. So what do we do here? What we're going to do here is that since stars are so far away, the image S1 prime always lands very close to the focal point, F1. Since telescopes or telescope tubes are long, one needs the eyepiece to have a long focal point. So picture-wise, what do I see here? I could imagine that I have a star. And maybe I have, I don't know. And so when I'm looking at the star here, we could imagine that you get some type of image like this. So let's say that I'm looking at the stars in the sky. And in this case, maybe I have and then I finally am going to look at my tube here. So if I look at my telescope tube, I imagine that I have my lens. Okay. And if I have my lens, let's say that this right here is going to be my objective lens. But I typically have this in a tube, a long tube. And then right here, I'm going to have my lens for the eyepiece. So right in here, I'm then going to have my eyepiece right there. So what I'm seeing here is that I'm seeing the light coming in. Then at some point, they're going to cross and that's going to be close to the focal point. And then the sky is going to come here. And then the light comes out where now you have your eye looking at this. So here is the objective length or the objective lens. And right here, this is going to be very, very, very close to the focal point. Okay, so this is going to be the focal point of the objective. And then right here, this is, now I'm going to choose at the same point here. So this is the focal point of objective, but very close to here, I'm also going to put the eyepiece focal length right here too, or focal point. And I didn't label this, but this is the eyepiece lens. So let's draw that. So if I do this, let me see. So I kind of set this up. Let's see if I copy everything this time. So if I look at this guy, I'm going to set this right here. And so now let's start looking at this. So I'm going to be careful on how I set this. So remember, F1 typically has a shorter focal point. So let's draw these guys in. So I'm going to say that this is the focal point of 1, right there. And in this case, I'm going to pick F2 to have a longer focal point. And in this case, I'm going to say that it's twice. So instead of 1 square for F1 on F2, I'm going to pick 2 squares. So note that these two focal points land at the exact same spot. So let's do this here. So the first thing I'm going to do here is I'm going to have some image that's way out here, that it's going to be far outside. Let's say that I start right here. And so this is S1. So now let's look at my ray diagram. Now this thing's going to be huge. In fact, I'm going to have to move this down. I should change it, but I'm not. Let's see. Yeah, that's going to be a long ray diagram. So now let's do it. So the first thing that I'm going to do is I'm going to draw my ray diagram. And remember, I'm only going to do this just a little. I'm going to erase to try to reduce the rays. So here's ray number 1. And then it goes through here. Goes through the far. And then I'm going to need ray number 2, which is going to go through the focal point. And then I'm going to come back and I'm going to erase this so that it's easy to identify where I'm looking at. So what you're seeing here, there's ray number 2, there's ray number 1, and look at the image that it's going to produce here. So the image that it produces here is going to be an image close to both focal points. That is image 2 here. So if I look at this, then this is what I'm seeing here. That this guy right here, from here to here, that distance right there, this is S2, S1, excuse me. And now I have a second distance, which man, I don't know where to put this at. It's going to be in the way, so I'm going to move it down. This is image S1 prime. So that image now becomes the object of lens 2. So I have to go to the far focal point. Okay, here I go. So let's look at the first one I'm going to look at is I'm going to have to extend this. No, I need a longer straight edge. Well, I don't have one handy, so I'm going to have to do multiple things. So the first one, I'm going to do ray 2 first. So ray 2 goes like this. I start off at the point, and I got to go through the center of the lens. So it goes this way, so now I got to start going backwards. In hindsight, I should have changed the focal length of this guy. I should have made him smaller. But this guy's going to be way out here. Now, let's get ray number 1. So ray number 1 goes parallel. And then it goes through the focal length or the focal point. So then it's going to go through here. But now I got to follow this back. Oh, I thought it was going to be way farther. Oh, that's even better. So then if I look at the image is going to be this guy right here. So I didn't need this. So if they cross right there, you could now see that I could now come in and talk about my object distance, which is this guy. This is the distance from the image S1 prime. Now this becomes object 2. And then this distance from here to here is now the final image S2 prime. So if I look at this thing, we could see here is that the image characteristics show similar, very similar traits to a microscope. We see that it's inverted, it's larger, and it's virtual. And we can clearly see that the second lens has magnified the image. Right, so the magnification has increased the image S2 from M1 to M1 times M2. Now, the last thing I want to do here is that I want to talk about virtual objects. So we just showed 2 of the most common optical instruments. We've talked about real objects, we should talk about virtual objects. And this only occurs in two lens systems. So as we already stated, real objects always occur for a single lens. For a two-lens system, the possibility of a virtual object occurs. And what the way you get a virtual object is that this happens when image S1 prime of lens 1 lands on the right side of lens 2. So here's an example that we'll look at. And this example is that, how do I say it? So here is an example of such a situation. And what I'm going to do here is I'm going to say that lens 1 is a converging lens. Lens 2 is going to be diverging. So this is going to get messy. So let's see if I can try to make this clear of how this images. So again, I just set up my lens system right here. So I need to identify my focal lengths here. So here's my first focal length. I'm going to say that F1 is positive. So I'm going to have, so this guy's going to be 2F1. This is going to be F1. And what I did here is that I put F1, the far focal point, exactly at the lens. And this is lens 2, which is negative. Now what I'm going to do here is that I'm going to put my focal length of lens 2, which is negative. I'm going to make this 3 squares instead of 2. Now, I don't really need the second focal point, the far focal point for the diverging lens, but I just put it there nonetheless. So now I'm going to take my object, and let's say that this is my object right here. I'm going to have this object be 2 squares high. I should extend my central axis, but I won't. And so now here's my first ray. So when I look at this thing, ray number 1 goes like this, goes parallel, then it's got to go through the far focal point, which now goes like this. Now remember, I'm going to erase this ray to keep it clean. Okay, so then it goes like this. Now I need my second ray. So the way I'm going to pick my second ray, see, I'm going to go through the center of the lens And it's going to look something like this. Okay. Didn't really go through the center of the lens. Let me try again. You try that one more time. I think I drew the exact same ray. So now I'm going to come back and I'm going to erase this. So now I have an image, and this is the image. And what you're seeing here is, look what happened. If you look at this guy is on the right side of the second lens. That tells you that that's a virtual object. Now remember, the second lens is diverging, so therefore the near focal point is the most important. So let's do that. So then we do the exact same thing as before. The ray goes parallel to the axis, to the central axis, and then it goes through the focal point. But in this case, it goes this way, but remember, I got to follow it back now. But this is ray number 1. Then the second ray, let's pick a different color here. Actually, I'm going to pick dark green. This one has to go through the center of the lens, of lens 2. So then if I do that, that's actually following in the same way as this guy. And where these guys cross, I'm going to have my image right there. And I'm going to say that this guy, so if I look at this distance from here to here, this is my final image 2. And so now let's just make a couple of notes and then let's move on. So once again, the first thing that I would note here is that note S1 prime is on the right side of, I'm going to have to lower this, is on the right side of lens 2. That implies here that S2, which is proportional to S1 prime, is now negative in value. So you have to put that into your equation as negative. And so what you're finding here is that as a consequence, I'm going to get an inverted image. It's going to be smaller. And in this case, it's going to be real, since S2 prime is to the right of lens 2.